So all the friends, ladies and gentlemen, good morning. Thank you so much and for Volta Platinum inviting me back to Shanghai Platinum Week again. And I'm going to share with you about R&D and practice of platinum. And you can see, and my topic is on the platinum catalyzed development of sustainable aviation fuel and emerging market. And let's have a look at the definition of SAF. So SAF is a renewable or waste-derived aviation fuel that meets sustainable criteria material, and it comes from the renewable resources and energy. So why we need to develop SAF? Because it is related to the global warming due to the Paris agreement, and we still need to limit the warming and to 1.5 Celsius to 2.0 degrees Celsius. And we can see that for the aviation industry, due to economic development, and we clearly see that the aviation industry has been developing very fast. Although an industry was affected by the pandemic, however, in year 2024, China's civil aviation passenger volume reached 330 million, and the global total air passenger reached 4.99 billion. So that's why you clearly see that aviation industry contributed to 1 billion tons for the carbon emission. So that's why we still need to consider that, because the aviation industry is increased by 3% per year. It is estimated to by 2050, and you can see the passengers and air passengers will be doubled compared with now. So that's why it is very urgent to reduce the CO2 emission of the aviation industry. And we can clearly see that the carbon emission for aviation industry, although accounted for 2%, however, you can see the impact on the global warming is far more than 2%. So because we can see, and for the air emission, do not only emit CO2, also emit the water vapor, nitrogen oxide, and sulfide, and the airplane exhaust, and due to very complicated the air atmosphere, so you can see emission is doubled in the air. So although you can see, and for the CO2 emission only accounted for 2% of total CO2 emission, however, the aviation industry, the impact of global warming achieved 4 to 6%.
What's more, the pollution as a result of the emissions from the aviation industry harm human health as well. According to some experts, China's aviation industry has a huge impact on China's air quality and human health. You can see the spatial distribution of such impact depending on the frequency of flights and on the density of airports. Take Beijing as an example. Beijing has 2 airports, and all the flights every day, they emit about a quarter of all the CO2s of all the roads transport. So the aviation industry emissions of PM 2.5 leading to O3 distribution, and considering the density of population, it's fair to say that aviation industry has a huge impact on the Yangtze River Delta region in Beijing, Tianjin, and Hebei. So it's urgent for us to protect the air and protect human health by limiting emissions from aviation industry. In 2016, ICAO passed a CORSIA representing the fact that the aviation industry is the first industry where there are specific measures that have gained consensus by governments of the world to reach carbon neutrality, and by 2050 the goal is to achieve net zero by 2050 for the international aviation industry. Why 2050? Because firstly, we have to attain the 3% growth, and secondly, no more than 2 degrees Celsius compared with the benchmark year. Only by achieving net zero by 2050 will we be able to attain the goals as set in the Paris Agreement. So in addition to rely upon technological breakthroughs on the part of engine and on optimizing management, the key source of emissions reduction comes from fuel aviation fuel, aka SAF, because of air fuel contribute a lot to the emissions. That's why SAF can play a key role in bringing down CO2 emissions from the aviation industry. Why? Because after burning, CO2 is emitted back into the atmosphere. So compared with conventional fossil fuel that are extracted from underground, the CO2 emissions efficiency from SAF can reach more than 80%. In the meantime, relevant studies have shown that after green fuel is used, not only will CO2 emissions be reduced, but also as SAF represents synthetic fuel, it has better proportion of hydrogen, which means that the hydrogen-carbon ratio is higher, leading to lower soot, which can also reduce non-CO2 emissions into the atmosphere. Some studies have also shown that with limited supply of SAF, it is necessary for the optimization of SAF distribution because CO2 emissions from the aviation industry show strong pattern of cyclicality and day and night differences, which means that if SAF is used at night, it can achieve highest efficiency of CO2 emission reduction, and in winter, the cost effectiveness is the maximum. Again, why SAF and the outlook of SAF? According to ICAO, SAF's current use is disappointing because we planned for 358 million tons of SAF by 2050. In order to achieve that goal, by 2030, SAF must reach 18.35 million tons, which means 30 times larger than the 2020 amount, which stood at 50,000 tons. So, according to the planning, we should have consumed more, far below the 2% requirement as was planned in the roadmap. The key limiting factor is price due to limited supply of SAF. SAF currently is 3 to 4 times more expensive than conventional air fuel because of its limited supply and because of the cost of the raw materials used to produce SAF. So from this, you see that the premium of SAF, as is indicated in the chart, the premium of SAF is compensated by policy subsidies as well as by companies showing their social responsibility. So SAF's challenges, the challenges that we face in developing SAF, companies pay attention to SAF supply, and government also pay attention to SAF supply. Producers pay attention to supply of raw materials as well as cutting-edge technologies. In other words, technology, government, market, they must be playing a role together in order to develop SAF. So for the development of SAF, ICAO has created this SAF Global Framework, which is composed of policy planning, regulatory framework, implementation support, and funding support to regulate and coordinate SAF development globally. In fact, around the world, 47 SAF-related policies have been issued, and more than $40 billion investment have been encouraged to have been put into the development of SAF. China is an important force developing SAF. President Xi Jinping announced a goal of China will take strong measures to reach carbon peak by 2030 and carbon neutrality by 2060. That was President Xi Jinping's bold claim or statement in 2020. In order to attain both carbon goals, the Chinese government issued a number of carbon-related actions with specific stipulations on development of SAF. Starting from last year, some airports in China, 14 airports in China actually 4 airports, 12 flights in China starting from last year started pilot injection of SAF. Sustainable development. Well, SAF, if you want to produce SAF, as SAF has the word sustainable in it, the raw material used to produce SAF must also be coming from sustainable source. So currently there are 5 classes of SAF raw materials that meet CORSIA standard. In the meantime, as SAF is used for aviation, it is special and the production processes must get approval. So currently there are 4 standard, the China standard, US standard, and standard proposed by the 8 petrochemical companies or petroleum companies. In China, we have approved 2 processes. One is Fischer Trophy synthesis or FTS as indicated in GB 6537, and the other is HEFA as indicated in 6537 2018, and US has approved 8 processes. Currently speaking, in terms of China's FTS process and HEFA process currently produces about 85% of all the SAF produced globally, which represent the biggest, the mainstream process used to produce SAF. So again, only by adopting the raw materials and the processes that have gained approval from either civil aviation organization or national government as indicated in their requirements as indicated in their requirements, SAF meet the sustainable requirements. Again, SAF as is used in aviation industry safety is a big concern. So there are specific requirements for some specific properties. Freeze point is one such requirement because aircrafts usually fly at an altitude of 10,000 meters, so the freeze point is below -47 degrees Celsius, and the components of SAF is different from the component of aviation kerosene. The biggest difference is that SAF is mainly composed of N-alkylanes, isoalkylanes, as well as other types of alkalines. So for N-alkylanes do not meet the freeze point requirements specified in the standards, whereas isoalkalines offer advantages including higher energy density. As for FROMA, or aromatics mainly the combustion of aromatics are not clean. All in all, it means that we have to develop in a massive way ISO alkanes as well as cycloalkanes. But as you can see, that N-alkanes has you cannot exceed a certain level, otherwise it cannot reach the freeze point requirements. So currently speaking, out of all 11 processes approved for producing SAF, 7 produce N-alkyne, but N-alkyne should not be classified as aviation fuel. They should only be classified as biofuel or biokerosene. So there must be a step called that turns N-alkyne into isoalkyne, which means that this process allows you to turn biodiesel into biokerosene. And the core material is the highlight of my presentation. It's also the highlight of our conference, Platinum or PGM. So by adding injection and by putting through isomerization process, N-alkanes is turned into isoalkanes. Otherwise, you cannot produce biokerosene. So from our perspective, we have been paying a lot of attention to this research of isomerization of alkanes, and we have to develop highly efficient techniques and processes to produce aviation fuel in an efficient way. For one thing, we develop molecular materials, and secondly, we have to make sure that our developed molecular materials are combined with PGMs in an efficient way. We published a lot of papers, and we managed to come up with the so-called PIC, or paraffin isoconversion technology. This technology allows us to convert N-alkanes into isoalkanes in a highly efficient way, and this is only an economical molecular restructuring process that doesn't produce any byproduct. The product can be used in a couple of areas to produce biodiesel, as well as other areas. It's a sustainable process. We have applied for more than 20 patents for our materials, and we have applied for our catalyst, and we have applied for more than 20 patents for our processes as well. So, but you think about molecular material. Molecular material has a nanometer level channels. So whether platinum is located inside the nanometer sheaths or at the mouth, well, basically our research shows that if its location is right at the mouth of the nanometer sheaths, then you can have the highest yield of SAF. So if it sits right at the pore mouth of the zeolite, you produce SAF with the highest yield. So we have produced some catalyst, and such catalyst allows us to distribute more than 85% of the particles right at the pore mouth of the zeolite, which means that only moderate use of platinum, we can greatly improve the yield of SAF, which means that we only use half of the platinum material compared with conventional catalyst, but the yield is 2 times high.
So for this excellent performance of PIC catalyst, so can achieve very high yield of multi-branched isomers. And you can see the icing point would be lower and the liquid would be better. And you can see, and this technology is used in the traditional and petroleum industry. However, we use this hydroisometric dewaxing of lubricating base oil based on PIC technology. And based on the FT SPK process built based on PIC technology, and we use the leading precious metal hydroisomerization cracking catalyst, and we use the original single cycle sulfur-free integrated separation process, and then we have the FT SPK yield richest international leading level, and we promote this ESAF, and this is the key for today's meeting, and HEFA SPK process based on PI technology. So this is the Dalian Institute together with Valtra Platinum, and we have this HEFA SPK process based on PEAK technology, and we adopted advanced oil hydroxygenation pretreatment technology and the leading precious metal HVO hydroisomerization catalyst, and we have our patent, and the Dalian Institute together and with Valtra Platinum. and we co-developed this SAF technology. And we use the catering waste oil and the palm oil and like a soybean oil, and we use different oil, and we achieve the high yield, meet the ISO and the US standard, and we basically meet all of the standards. And by the high efficiency and of the hydrogenation of grease and oil operates and with high stability. And this technology is playing a leading role. So for this SAF technology, together with an HVO, hydrogen, and it could achieve over 80% of the capacity. And for now, and there are more than 5 million tons of the usable bio oil, so it is very important. And this technology, you can see that we are working with Nanjing Bioenergy and company, and we will build a demonstration of 500,000 tons of industrial grade oil to biodiesel and sustainable aviation oil. And you can see this demonstration and of 500,000 tons of industrial grade oil-based biodiesel and sustainable aviation fuel. And you can see, and this device, or we consider this as this demonstration, could consume more than 400,000 tons and of the wasted biofuels. And the annual output value is 4.4 billion renminbi, and the investment of SAF can reduce the emission by 1 million tons. So that's why, and since the operation this year, we could see the facilities and this construction, and can help to achieve very good social effects. And you can see that. And for this SAF development will generate more demand for platinum. So each 1 million SAF capacity require more than hundreds of tons of precious metal. Okay, so it's already come to the end of my report. Of course, and it is the shared responsibility of the international community to control the greenhouse emission. And we develop a SAF and can help to achieve the green transition for the aviation industry, and then contribute to the double carbon goal. Of course, and the platinum and is very important. Is very important to the key technology of SAF, and we are together and with Valtra Platinum and to have this peak technology and can provide a solution to the whole industry. Thank you so much. Of course, and this technology is also supported by the Chinese Academy of Sciences, Ministry of Science and Technology, Liaoning Province, and the Xinjiang Autonomous Region. Thank you.